Okay, there's a candy store. Right now they're selling 32,000. No, wait, sorry. There's not a candy store. There's a company that's creating soda. They sell 32,000 cans per month, and they're 75 cents each. So you can multiply those two numbers to find out how much money they're bringing in. But there's something that changes. There's something that could potentially change their price. They found out if they if they increase the price by a nickel, then they lose 1,500 sales of cans because the price is like, apparently some people are like, okay, that's 80 cents. No way, I'm not doing it. Okay, so what you want to construct is a revenue function, and the revenue is going to be the number of cans sold times the price, right? Right now, it's 32,000 for cans, and it's 75 cents for the price. You multiply those, and that calculates your revenue. But this can fluctuate. We said that there's 32,000 cans, but if we here, and then we have 75 cents for the price. But they said if we increase the price by a nickel, so 0.05, then we will lose 1,500 sales of cans. Okay, that's just one increase of 5 cents. You could do two increases of 5 cents, and we're left to assume that it means we lose 3,000 sales. So put an X here and put an X here. And X represents the number of times we increase the price by 5 cents. And this represents the revenue based on X, the number of 5-cent increases in the price of a can. You're asked to find a graph. These graphs are pretty ugly. I'd rather do part C first because part C is asking you to find the maximum revenue. Okay, so take that revenue function that we just found, which was 32,000 subtracted by 1,500x, 0.75 plus 0.05x, and then you want to maximize it. So this is a quadratic, okay? And if you distribute it, that can help you get a better idea of what the shape of the thing is going to be. So if we multiply that 32,000 times 0.75, get 24,000. 32,000 times 0.05x, get 1,600x. Then the 1,500 times 0.75, that's negative 1,125x. And then multiply these two together. So it's negative 75x squared. It's quadratic, like we said. And look, A, the leading coefficient, is negative. So that means the graph will be looking down something like this. So the vertex is going to be the maximum revenue. Okay, the vertex will represent the maximum revenue. So we've got to find out what that vertex is. So let's clean this up a little bit. 1,600 minus 1,125. That's 475x. And then to finish getting x by itself, well, sorry, we're not getting x by itself. We're done. This is basically in standard form. You could rearrange it a little bit so that you have descending powers. But we wanted it in this form because to find the vertex, we can use this nifty little formula. This is the x-coordinate of the vertex of a quadratic, where b is the coefficient of the x to the first term, and a, is it really 7? Oh, this is going to be yucky. A is the leading coefficient, so negative 7. And so I'll convert that to a decimal. I made up these numbers. Hopefully all the other numbers are, the numbers for your problem will be nice and clean. So I'm doing negative 475 divided by negative 14 in my calculator. I got 33.9285. Okay, so I'm going to say it's roughly 34. It's a little bit off, okay? But again, I think that any textbook is going to have it turn out to be an integer. I just made up these numbers on the fly. So I plugged in my A and B into my vertex formula. I found out x should equal 34. That's not the price. That's not the number we sell. That's not the total revenue, right? Remember, x represented the number of times we increase the price by 5 cents. Okay, so if we want to find out the charge per can to realize their maximum revenue, you want to plug in 34 back into this part of the function, because this was the stuff that was talking about the price, right? The can started at 75 cents. Then we want to increase the price 34 times by 5 cents. So take 0.05 times 34 and add that to 75 cents. So apparently in this situation, we'll make the most money, if we plug in x equals 34. So if we set the price to be $2.45. So the price per can should be $2.45 in my problem. And now what is the maximum revenue? That's where you plug in 34 into the entire function for revenue. You could do it in this top one or this bottom one. They're both going to give you the same thing because we just rearrange it. So I'll plug it in the bottom one because there's one less x to plug it in. So I'm replacing x with what I found the maximum to be, 34. Okay, so I'll do this with my calculator. I got 34 squared times -7. So it's going to make negative 8,092. And then we've got 475 times 34. Add that negative number. And then we've got to add the 24,000. So it's 32,058. That's our maximum revenue. Okay? And so that's also the y coordinate of the vertex. This is 34, comma, 32,058. When you plug in 34 into the function, you get out a y value of 32,058. So for a graph, that means that x equals 34. The y-axis should be around 32,000. So that's all I'm looking for as a teacher, is that students know roughly what this graph looks like. That's the vertex. And then since a is negative, this is a quadratic that's facing down like this. So as long as I see a rough sketch like that, I'm happy.